Hey everybody, it's Professor Williams, and we're going to construct a box plot and use it to check for outliers. So the first thing that we have to do is we have to sort our data, and always sort it from the smallest to the largest before you begin. So my data is the number of days, and I've got it sorted for you here. The first thing we're going to need to create our box plot is this 5-number summary. And it's simply the largest, the smallest, the median, and then the first and third quartiles. So I looked at my data and I found that the largest value that I had was 82 days. The smallest was 13. Now I had an even number of observations, so in order to find this median, I simply took the middle two values, added them together, divided by 2, and that gives me my median, or Q2, equal to 39.5. Now we're going to find the first and the third quartile. All right, remember that when we're looking for the first quartile, we have to find an index value first. Right? And we're going to do that by dividing the percentile that we're looking for by 100 multiplied by the number of values. And remember, the first quartile is the same thing as P25. So I've simply taken 25 divided by 100 times 30. Gives me 7.75. I'm going to round to the 8th position because I is not an integer or whole number, and now I know that Q1 is 34. Remember, if I had been an integer, i.e. whole number, then I would have averaged my 8th and my 9th values to find my index. So I'm going to use the same procedure to find my third quartile, remembering that my third quartile is the same thing as P75. So I'm simply going to take my 75 divided by 100 times 30, and that's 23.25. Again, not an integer, so rounding to the 24th position, counting down from the smallest towards the largest value, I find that Q3 is 51. Always remember, if I had been a whole number, you would have simply averaged the 23rd and the 24th values. The last things I need in order to do my box plot is I need this interquartile range, or IQR, and that's simply Q3 minus Q1. So we knew that Q3 was at 51 minus 34 gives me an IQR of 17. I'm going to use this two places. One, it's going to be the width of the box, but it's also going to help me construct these fences that will help me identify outliers. And so I need an upper end and a lower end. So to find my upper fence, I'm going to take Q3 and I'm going to add 1.5 times the IQR to it. So I knew that Q3 was 51, IQR was 17. Multiply that together, and that gave me 76.5. So for my lower fence, I'm going to start at Q1. I'm going to move to the left. So minus 1.5 times the IQR gave me this 34 minus 1.5 times that 17. And so I know my lower fence was 8.50. Now I finally have everything I need to make this plot. So from the magic of computers, here's my box plot. So my box, the width from this hinge, lower hinge, to this hinge, that distance is simply the IQR. And my box is hinged by Q3, or 51 on the top, and Q1, 34 on the bottom. I place my median, right, hopefully properly located, inside of the box. My whiskers run to the smallest value, which in this case was 13, and to the largest value, which in this case was 82. Now remember, we did those fences. So my lower fence was 8.5, my upper fence was 76.5. The secret to the fences is we know that anything beyond that fence, anything that falls out here or out here, is going to be an outlier. So we have empty space on the lower end, so no low outliers, but when we look up top, we find 82, okay, and it's a relatively mild outlier, but still an outlier nonetheless. It probably needs to be removed from our data set before we begin our analysis, just to give us a little bit more symmetrical and close to normally distributed data. So that was kind of a quick run through, but I hope that you found it useful. And as always, thanks so much for watching.